Okay, sorry about earlier. I think I made several mistakes inside the last video, and I think it was also not very well organized. So I'm kind of going to walk through the Digital Systems 3, like the main takeaways and notes that I should take know. So first is like there is unsigned, which we represent as binary of that. So for instance, the example I gave earlier was 10. Signed, we just represent as two complement, which we do as this. And then the bar on top is big bitwise negation. So 10 is 10 gives 0, 101, which evaluates to 5. And arithmetic negation, which is negative n, is just basically adding 1 to the flip bits, which evaluates to this. So this is basically the idea that the negative of 2 complement of a is equal to 2 complement of the flip bits plus 1. So that's how it works. Yeah. So CPU doesn't actually do like subtraction, it finds the negation, then what is it called? Then a add thing to it. So that's how it works. Um, I guess yeah, two complement is just everything added up together, subtracting it from the last most significant bit. To flip it, we kind of just do this. And then yeah, B minus A is just B plus negative A. And then the edge case I talked about. This one was relatively clear. Negative 128 cannot be represented. Um, and then the two branches that are main that are relatively harder to see are branch less than, branch low if lower. So less than, this one is signed, this one is unsigned. That's the difference. And this one is just evaluating A minus B and checking if N not equal to V. And it works because in the normal case, when there's no overflow, so not V, it results in a negative number. So then A must be less than B. And then in the overflow case, V is 1, then we see that it was super negative. So then it looks incorrect. So it looks like it's positive. So then um, N is not equal to V. That's kind of like what we have. And in the case that's unsigned, we just kind of see evaluate A minus B and check if the carry flag is clear. So basically what it does is A minus B is just evaluated, taking the fliplets plus 1. Then what it does is if it's greater than the B, then it'll create a carry flag. So then it'll set the carry flag. If it's lower, then there'll be no carry flag set. So then we just basically check that it's not C. I hope that's more clear. That was the part I don't think I explained very well in the video. So using this one to kind of make up for that. Cool. Let's end it off here.